The third lesson on functions is regarding inverse functions. Now, for inverse functions, we should know that the inverse functions are the functions for which the range of the function can be mapped onto the domain, and the domain of the function can be mapped as the range of the function. Meaning, if for a given function, there is a domain and there is a range to it, then for the inverse function f inverse x, we can say that the domain maps onto the range and the range maps onto the domain. So to understand it more, if we just try to understand it graphically, we can say that for the inverse functions, the functions are mapped along the line which is y equals to x. Meaning, if I give you a simple example as the function f of x, which is equals to 3x minus 4, such that x belongs to all real numbers. So for this function, if I need to reflect it, if I need to have the inverse of the function, if the question says find the inverse of the function, then what I can say is that the line y equals 3x minus 4 can be represented on the graph so that we can see that the gradient is a positive 3, therefore the line is sloping up. The y-intercept is a negative 4, so I can just make a line so that it slopes up. And roughly this is going to be the sketch of the function. This is my function fx. Now if I need to have the x-intercept, then I can simply substitute my y as a 0. For x-intercept, I can say it's my y, which is a 0, and for that I can say it's 3x minus 4, or x belongs to, or x comes out to be a 4 by 3 here, meaning this coordinate, this becomes a 4 by 3 comma 0. Now the next thing that I should do is to represent this line, or to have a relationship of this line with respect to the line y equals x. This line y equals to x actually gives us the inverse function, meaning if I just reflect the given function in the line so that first coordinate was 0 comma minus 4, that would become a negative 4 comma 0 after the reflection in the line y equals to x, or 4 by 3 comma 0 will be reflected as 0 comma 4 by 3. So that means if I again make the inverse of the function, then for the inverse of the function I can say that my inverse function f inverse shall be going in this direction, so that I can just reflect it in the line. This point where the function, the line y equals x and the f inverse function, they intersect. This is the common intersection point, or the common relationship for the function and the inverse function itself. So 0 comma minus 4 for the function got reflected in y equals x, giving us a negative 4 comma 0. 4 by 3 comma 0, the x-intercepts gets reflected, and I can say that this is 0 comma 4 by 3. So what I have seen here is that the domain value 4 by 3 maps onto the range value, which was a 0, or the function value, which was a 0, and the 0 is mapping onto the domain, which is a 4 by 3. So this is what we said in the beginning. Domain maps onto the range and range maps onto the domain. The x becomes y and the y becomes x, and this only happens when we reflect it in the line y equals to x. So this is basically the inverse of the function. Now this is what we have done graphically. If we are supposed to do it by calculation, then I can say that the given function for this case was y, which equals 3x minus 4. I need to make x the subject, as we are saying the domain is mapping onto the range and so on. So to make x the subject, it's y plus 4, which is equals to 3x, or x shall be equal to y plus 4 divided by 3. Now again repeating, x becomes y becomes x, domain becomes the range becomes the domain. Therefore, I can now say that x is my function and y becomes the domain value, which is x plus 4 divided by 3. So this is actually going to be the f inverse function here. And to have the relationship of the two functions, if they ask us to get the relationship of the two functions, of the function and the inverse of the function, then what I can do is, I have seen that the relationship is the point of intersection with y equals x. Meaning, if my given function is 3x minus 4, and for point of intersection, I can see that there are three lines. One is y equals x, and this third is the inverse, which we got as 1 by 3x and a plus 4 by 3. So I can just equate any of the two equations. The easiest method that I can see is to equate 3x minus 4 to y equals to x and solve them simultaneously, so that I can say this is 3x minus x, which is equals to 4, or 2x, which is equals to a 4, or x is equals to 2. Meaning, if y equals x, then 2 comma 2 is the point of relationship between, it's the point of relationship between the function and inverse, between the relationship between f of x and f inverse x. So this is simply what inverse function is. So let's do an example to get the concept more clearly. So for the explanation purpose, this question is from 2002, May, June, and it's question 10, but I really like the question for the purpose of explanation. So let's say f and g are defined by fx equals 3x plus 2. So they have given us the function f, which is equal to 3x plus 2, such that x belongs to all real numbers. And they have also given us the function gx, which is equals to 6 divided by 2x plus 3. And again, x belongs to all the real numbers. And x in the denominator, I should know that a function is never undefined. Therefore, for that case, our denominator 2x plus 3 shall never be equal to 0, because when this happens, any number divided by 0 gives us infinity or an undefined value. So in this case, I can say that x should not be equal to a 3 by 2, or x should not be equal to a 1.5. So this is something that they have already given in the question. So find the value of x for which f of gx equals 3. So again, that's the composite function. We need to find the value of x such that f of gx equals 3 here. So first, obviously, we need to have the composite function. We know f of x, which is equals to 3x plus 2. So to get the composite function, I should be substituting the x with g. So I can say that my f of g shall be equal to 3 times 6 divided by 2x plus 3, and then it's a plus 2. So the composite function in this case is going to be 18 divided by 2x plus 3, and I will be equating it to this value, which is a 3, because they have given us the condition that the composite function fg should be equal to a 3 here. So 18 divided by 2x plus 3 plus 2 shall be equal to a 3, or I can say it's 18 divided by 2x plus 3, which is equals to 3 minus 2, that's a 1. Or it's 18, which is equals to 1 times 2x plus 3, or I can say it's equal to 18 minus 3, which is a 15, and this is equals to 2x, or I can say x is equals to a 15 divided by 2, or x is equals to a 7.5. So this is going to be the answer for x value. The second part of the question. Sketch in a single diagram the graphs of y equals fx and y equals f inverse x, making clear the relationship. We need to sketch on the single diagram the graphs of the function and the inverse, making clear the relationship between the two graphs. So this is what we have done previously also, but let's do it again. So if they are saying it's the function which is 3x plus 2, we have the function which is equals to 3x plus 2, x belonging to all real numbers. So if I sketch this, the concept of the gradient direction and the y-intercept is very, very important here. If I sketch the graph, I should know that the gradient is a 3, the y-intercept is a 2, and it is the line which is sloping up. So it's the line which is sloping up. This is how the line shall be going. This is how the line of the function f of x equals 3x plus 2 shall be. So to show the relationship, I know that the point of intersection has to be the line which is y equals x. So I'm just making the line which is y equals x, and I have seen on the graph that this is the point which should be having the point of relationship between the function and the inverse itself. And also if I need to have the inverse, then I can see that the y-intercept was a 0, 2 for the function. Therefore, for the inverse function, it should be the 0, 2, the y-intercept should be reflected in the line y equals x. This was the line which we have already drawn for y equals x. And this line comes out approximately somewhere here. So to have the reflection, I should say that this is how the line should be for the inverse function. So if this is where the line should be for the inverse function, then the only thing left is to find the relationship between the two functions. We have very easily sketched the line of the function and the inverse function by just reflecting the y-intercept in the line. We do have the point of relationship, which is the point of intersection for the function, the line y equals to x, and also the inverse function. So to get the coordinates of the point of intersection, I can equate 3x plus 2 to the line which is y equals x, that is the line of reflection, and I can see that this is 3x minus x, which is equals to a negative 2, or a 2x which equals negative 2. Therefore x will be equal to a negative 1, meaning the point of relationship between the function and the inverse is going to be a negative 1 comma negative 1 here. So we have sketched the function and the inverse, and we have shown the relationship also between the two graphs. So that is the answer. Now the third part says express f inverse and g inverse in terms of x. Meaning first we have to find f inverse and g inverse in terms of x, and then we have to equate both of them to solve the equation. So let's get the inverse function mathematically or by calculation. The function which is given to us is for f of x, that equals 3x plus 2. And the g function was equal to 6 divided by 2x plus 3. So f inverse, obviously to get f inverse, I will be equating fx to y. I will be making x the subject, meaning this is going to be y minus 2, which is equals to 3x, or I can say x is equals to y minus 2 divided by 3. Once I have made x the subject and y the subject, and we know why we are doing this. We are doing this because we know when we are getting the inverse, the domain maps onto the range, meaning the x values map onto the y values, and the y values or the range maps onto the x values, which is the domain. So here I have switched the two. I have made x the subject so that now I can say that the inverse function is equal to switching y to x to the domain. It's x minus 2 divided by 3. So this is going to be my inverse function equation. In the same manner, I will be getting the inverse of g. I can say it's y, which is equals to 6 divided by 2x plus 3. My objective is to make x the subject. So cross multiplying both, it's y times 2x plus 3, which is equals to 6. Or I can say it's 2x plus 3, which is equals to 6 divided by y. Or further, I can say I should be taking 3 on the other side, so that this is 6 over y minus 3. And to solve with this 2, I can say it's 6 divided by 2y and minus 3 divided by 2. So x then will be equal to 3 over y minus 3 by 2, or I can say that g inverse is going to be 3 over x minus 3 by 2 here. So I can solve it further also, and I can say it's g inverse, which is equals to 2x is the LCM. Therefore, this value becomes 2 times 3, which is a 6 and a minus 3x. So g inverse is going to be 6 minus 3x divided by 2x. So this is going to be the g inverse function here. The question also asked us, we have g inverse, we have x, and we have g inverse, we have x f inverse in terms of x. Now the question has asked us to solve the equation for f inverse, which equals g inverse. So for f inverse, we need to solve f inverse, which equals g inverse. So I will be equating both the equations, and I can say this is x minus 2 divided by 3, and this is equals to 6 minus 3x divided by 2x. Solving it further, it is 2x times x minus 2, which is equals to 3 times 6 minus 3x, or it's a 2x square minus 4x, which is equals to 18 and a minus 9x. Making a quadratic equation, it's minus 4x plus 9x minus 18, and this is equals to 0. 2x square plus 5x minus 18, that shall be equal to a 0 here. So if I solve the equation, I should say that my values come out to be, it's a 36 and it's 4 nines are 36. Even if I factorize it, I can solve it with the help of calculator, or I can factorize it. I can say it's 2 times 18, which is a 36, and the factors of 36 are going to be 2x square minus 4x plus 9x. 9 times 4, that will give me a minus 36, and 9 minus 4, that would give me a plus 5. So just doing the factorization, the middle term break, I am getting x minus 2 and then plus 9 and x minus 2, which is equals to 0. So x minus 2 and 2x plus 9, which is equals to 0. So the 2x values that I can get here are 2 and a 9 by 2 here. So this is going to be the answer for the the f inverse equated to g inverse. What if uh, I give an equation so that f of x is equals to x plus 5? If I am supposed to get the f inverse equation, then for f inverse equation, I can very well say that it's y, which is equals to x plus 5, or Making x the subject, I can say it's y minus 5, which is equals to x. That means the f inverse shall be equal to x changed to f inverse, y changed to x, and this becomes x minus 5 here. So if they ask us to get the relationship between the two functions, now I would emphasize to just check the gradient value for both. What I can see here is that the gradient value for both of them is a 1, and here also for the inverse it's having a value which is a 1. So if the gradient value is a 1, then what we know about the direction is that the gradient or the direction being the same, both the lines, they shall be moving parallel to each other. Meaning, if I have the line which is y equals x, obviously this is the line of reflection that will be giving us the relationship between the two functions. But again, repeating, because the directions for both function and the inverse, they are the same. The gradient values are the same. So what I can see here is that the y-intercept for fx equals x plus 5 is a 5, and this is how the graph shall be. This is how it should be moving. And x minus 5, so I can see that y minus 5, obviously the x-intercept is a 5, and direction being the same, both of them moving in the positive direction, it's passing from minus 5. So I can say that this is the graph for the f inverse, and this is the graph for this. The first one is the line for the function, and the second passing through negative 5 is the graph of the function inverse here. So this might also be a possibility that if the gradients are the same, then obviously the two lines, the function and the inverse, yes, the inverse is present, but they will not be intersecting with the line which is y equals x here. Even if I check it by calculation and see that it's f of x which is equals to the x, which is y equals x, so it's x plus 5 which is equals to x, and I can see that the 2x, they are getting cancelled, and I cannot have any relationship between the two. So this condition happens only when the function and the inverse, they are parallel to each other, or when they have the same value of the gradient, or they are moving in the same direction.